Alright guys, welcome back. We're going to try another video. Hopefully this one will be a little bit shorter than the 10-minute or the 20-minute one that we did last time. But today we're going to talk about section 7, which is graphing tangent, cotangent, cosecant, and secant graphs. Okay, so we're going to talk about graphing these. And the very first one, since we've already done sine and cosine, I want to talk about tangent. Now, tangent's graph is a little bit different. If you take a look at, once again, I'm pulling up this site. If you take a look at tan x, it no longer has the nice up and down that sine and cosine have, but instead it goes infinitely up here and then it hops back down here, and then comes back up here, and then hops back down here, and so on and so forth. And if you remember, that is called the asymptote. See, it's right here. If this is pi, this is 0, this is pi over 2. So when you're graphing tangent, it has this asymptote, pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. So when we're graphing these, once again, we go by the unit circle. It intersects here at 0, intersects again at pi, intersects again at 2 pi. So every essentially 180 degrees, it intersects. Now, that's graphing tangent. And once again, if we would have, let's say we would have a 2 in front of here, that ends up making this, squeezing it, making the frequency much more frequent. Pi over 2, pi, 3 pi over 2, 2 pi, so on and so forth. And once again, if we would add 4, brings it up so that it crosses at 4. That's where it just shifts up 4. And if we would subtract 4, it shifts it down 4, so on and so forth. Same exact idea as sine and cosine, but the tangent graph is a little bit different. Now, if we're going to graph cotangent of x, I don't know if it'll do it. There it is. If we do cotangent of x, it does the exact same thing, except instead of it crossing at 0, crossing at pi, crossing at 2 pi, that's where the asymptotes are. The asymptote is at 0, pi, 2 pi, so on and so forth. And instead of it swerving coming up, it swerves and then comes down. So here it crosses at pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. So that, and once again with the period, the phase shift, the vertical shifting, it does the exact same thing. Now, once again, just like the Lesson 7.6 video, when we have questions, please don't hesitate to ask in class. Now, let's go back and let's explore the cosine, or the cosine of x graph. Okay, see, it comes up here 1, and then -1, 1, -1, and then it, here it pi, 2 pi, it crosses 3 pi over 2, pi over 2. Now, what would happen? Now, once again, if we have cosine, the inverse of cosine is secant. Okay? So what would happen if we did secant of x? That's kind of cool, actually. Right here at -2 pi 1, at 1, that's where the minimum is, and then it comes all the way up. And if you look, there's an asymptote right here at -3 pi over 2. And same thing here as pi over 2, 3 pi over 2. That's where the asymptote is. 1 and negative 1, where it peaks and where it valleys, that's where our new graph is. So the purple is secant. And the same thing happens when we deal with sine and the opposite of sine, or the inverse of sine, which is cosecant. Does the exact same thing. 3 pi over 2, negative 3 pi over 2, 1 is the minimum, and it comes up here. And then here at pi, that's where the asymptote is. 0 is the asymptote, pi is the asymptote, 2 pi is the asymptote. Basically where sine crosses our x-axis. Okay? And once again, in our book, it shows the exact same thing on page 578. Here at negative 3 pi over 2, it's minimized, and then here's the asymptotes. Okay, so that's that. And really, other than that, that is pretty much it in a nutshell for lesson 7.7. So pretty short video today. Once again, I'll shore up any questions as we come into class the next day. And if there's any other concerns, just let me know. Thank you for your time and patience, and I hope this was a good lesson for you.